Hi, I'm Jadi and let's continue the LPIC 1. We've reached 102, one step forward. It's about design hard disk layout. Weight's only 2, but I will speak a little bit more because I find this part literally enlightening. At least for me, when I understood this FHS, I believe that was one step forward from becoming a system administrator. Anyway, let's continue. Candidates should be able to design a disk partition schema for a Linux system. Notice, should be able to design. So you need to understand the file systems. I mean the FHS, which we will speak about here, FHS, and you should understand the concept of partitions. In this section, we are not going to do the formatting. We are not talking about file systems, and we are not talking about partitioning itself. That's separated part. We're just trying to design hard disk layout. But I will speak a little bit more because I believe it's super important to understand FHS. You should be able to allocate file systems and swap space to separate partitions. Tailor the design based on what system you are going to use. Ensure /boot partition conforms to the hardware architecture, and knowledge of basic LVM. As any other modern recent operating system, I mean Mac and Windows, Linux uses files and directories to organize files. It might be a fun fact that in older times, some operating systems didn't have folders. Even on some systems, there was no concept of a general file which can be used by different programs. Files were connected to their own programs. Nowadays, you can see this on your, for example, iOS or on Android systems. You open a program, it has some files which can use them. If you open your, email composer on your tablet, you won't see the specific files for different emails. Even if you are working with a video editor on your Android, you won't see different files. You just drag and drop from other softwares and save your project. Next time, if you open the same software, it will show you same files. But if you browse your file system, you normally won't see exact project name, which is possible to open with any file. Anyway, any program. Anyway, nowadays we have folders, which are called directories in the Unix world. Folder is a Windows concept, I think. And we have files. If you are familiar with Windows, you have this drive C, drive D, drive A if you have a floppy disk, drive whatever, F if you have a network disk, or whatever. In the Linux world, we don't have this. In the Linux world, everything is structured under one huge tree-like structure. You have one root directory, which is known as /, and all other files are located here. Maybe you have a home directory inside your root, so the path will be /home / for example, for user Jadi, you will have this directory. If user Jadi has a desktop directory, it will be here. And if you have a file here, your file will be located here. As you can see, it's like a huge tree. This works based on a standard. The standard is called Filesystem Hierarchy Standard, FHS. I think the latest version is version 3 and published on 2015. Even if you connect the USB disk to your Linux system, you have a Linux system, it has a hard inside it, this tree structure thing is here, FHS, and you connect the USB disk called My Disk. The Linux subsystem, different subsystem, you've seen some of them, will recognize this disk and will mount this disk somewhere. For example, under media, my disk. And now if you go to the directory media, my disk, you will see the contents of this disk. If you connect a network drive somewhere, mount a network file system in your system, you may mount it under a /mnt/net disk. So now if you go to /mount/net disk, you will see this network storage you have here. Still it's under that huge tree. This is the difference between Windows and Linux. On Windows, this might be, for example, drive Z. In Linux, it's mounted somewhere in that big hierarchy. The enlightenment I talked about you refers to this part. This is a FHS standard, which was File System Hierarchy Standard. This way, you will know what directories you have on a Linux system or on a Unix system based on the standard. Sometimes some even Linuxes, GNU Linuxes do not comply to this standard and invent their own thing. Or on a Mac machine, you don't have all of this like this. They change some part, although Mac is a Unix. But for me, when I learned this thing, I was able to find my way in a Linux system. Even if someone tells you that on Nginx configuration, we have a problem. We checked and you can only have 20 concurrent connections. I want to increase to 50. And you don't know shit about the Nginx. If you know this, FHS, you will know that, okay, Nginx is a program. I don't know what it does. So, if it's a program, it should have a configuration. I know FHS. So I know that all the configurations should go into etc. So I will go to etc and see if I have an Nginx directory. If yes, I will go there. There should be some conf files there. I will check if any of them has a configuration for number of concurrent connections. If yes, I will increase it to 50 and I know systemd and I will restart the Nginx service. This way you will find your way. This was my enlightening moment in the Linux world. Let's have a look. Here I have my Fedora. So let's open a terminal. Increase the font size a little bit. cd/. I will do an ls and you can see that I have the directories we were speaking about. For example, etc, boot, dev, home. The color is very bad. Lib. Let me change the color. Switch profile to default. Okay. I've heard that light background will help people see better on the videos, especially people with eyesight problems. Not sure what the correct word is. Anyway, as you can see, we had those directories we speak about. Boot, dev, home, etc, lib, lib64 for 64-bit libraries. Media, lost and found looks very interesting, but we won't speak about this now. And it's not interesting. Very nice directory, but practically nothing important there unless you recover something from a crash or something. We will see this later on the next chapters. mnt opt root proc, you've seen it, contains processes information, run, user, var, temp, sys, and sp. Here I will go through the FHS standard and will describe this. The first one is the bin directory. It contains essential command binaries. These are the commands we mainly use under Linux. So let's go to the bin. Here you have the essential commands. People have an issue with my keyboard. I think it needs more charging maybe. The commands people normally use under Linux are located here, like bash, this environment we are working in, like ping. If you do ls pin, you see different commands are here, including the ping command, for example, and other stuff. If you are doing a tar to compress files, tar is located here. So /bin contains essential command binaries. /boot is used for booting the system. You've seen this in previous chapters. For example, under boot, you have the grub, your bootloader. We will see in the next chapters in more details. You have the VM Linux, which is Linux kernel binary. You have the RAM. Let me go there and do a directory. Control L will clear the screen, so I can go to /boot ls. You can see EFI directory. If I'm on a UEFI, I have files here. You have the grub, you have the VM Linux files, which are Linux kernel binaries, and for each VM Linux with whatever version and configuration you have here, you have one init RAM FS, which is the initial RAM Linux needs to read the main drivers and whatever it needs to boot the system. So /bin was binaries, /boot is whatever system needs to boot the system. Then you have /dev. We've seen this, Control L, and directory /del, all dev, all the devices. This is a virtual file system, pseudo file system, not a real one. But you have whatever device will have a file here, like your terminals, keyboard and monitor in a normal way, your disks, floppy disks, whatever, your SD, blah, blah, which are your hard disks. Where are they? Can you see any SD? SDA, SD2, partitions, first partition and second partition of the disk. We'll speak about this later. And whatever device you have is in /dev. etc is the most important one, in my opinion, to know. Contains the configurations. It says host specific system configurations. So you will have different files here, and each of them will configure something. You remember when we were speaking about the systemd configurations, it was in etc blah blah. When we speak about DHCP, configurations, DHCP will have a directory here for sure. cd DHCP says you don't have permission. I will become root. So let's go to the etc DHCP configurations are here. Whatever configuration, if you are checking if RPM is working with this configuration or not, you will go to the etc RPM. So if your manager told you that I've installed VSFTPD and VSFTPD doesn't accept normal users to log in, can you check the configuration? You may not know what VSFTPD is, but you can go to etc VSFTPD and see what configuration you have there, or search and read the manuals, which is a better way. /home contains all the users' home directory. So on this system, I have only one user, which is Jody. So Jody has a home here. I can do a long ls, which is very famous. Many people use it. -ltrh. Show human understandable sizes. Long, show all the data, and sort based on the time reverse. So the newest files will be at the end. There is only one directory. We will see all of this later, which is Jody. So I can go into the Jody. No pun intended. And I have some files here. pwd will show you where you are at the moment. So in Jody's home, we have desktop, documents, download, music, whatever file Jody has. So each user kind of has a /home/Jody. Next one is lib, contains essential shared libraries and kernel modules. Shared libraries are libraries that other programs may use. If you want to read something from a keyboard, you use a library to do so. We will speak more about the libraries in next chapter. But on /lib, you have all the important shared libraries and system kernel modules which you can load or unload or whatever. All are here, so everyone shares them. On the modern systems, we have one lib and one lib64 for 64-bit. libraries. So what we had up to now, I will do a quick review. Bin, essential commands were there, /boot files needed to boot the system, dev were devices, etc were configurations, home, user homes, lib, libraries or kernel modules. Media and mount I've already kind of covered. As I told you, on Linux, you can mount other file systems into your system. If you have a new USB disk connected to your computer and it's called MD, my disk, it will be automatically mounted under somewhere, sometimes media empty. And if you go here, you are in this USB disk and you will see the data. If you add a new external device to your computer, it will be on /media, its name, external. These are all configurable. I'm just talking about a very general Linux, if it's external. If you have a network device somewhere and you want to access its files, you will create under MNT, you may call it net, and then mount your network device, whatever the address is, on MNT net. And then all the files here will be accessible on this path. This is how Linux manages external devices. Based on the FHS standard, media is used for mount point for removable media. MNT is used for mount point for mounting file systems temporary. Some modern systems for desktop do the same thing under /run. So you cannot always be sure if they are complying to this idea or not. But anyway, OPT, let's go to OPT. CD OPT, sorry, it's empty. We install a Linux and then we install some services from the repository with commands we know. For example, a web server, a FTP server, they are all installed under their predefined location. For example, you know, the binary might go to /bin. If I'm installing, for example, a FTP server, its binary may go here. Its configuration will go here. Its log will go under /var/log. But sometimes you install a server and then you go and install one very specific program on this server. For example, you buy a scientific package somewhere, or you install Elasticsearch. It's advised to install it under OPT, so it will be separated from your system. That's why we have this /OPT. /root is the home folder of the root. Don't be confused about the root. We have one root user, which is the privileged user under this, the most privileged user under this operating system. It's called root. We have one root directory, which is /directory. We call this root, and we have one very specific directory, which is /root. That's the root directory under the root directory. Okay, this is the home of the root user. If I do /home, you can see I only have a home for Jody. If I want to go to the home of the root users, I will go to the /root. pwd, it says you are in root. It shows it like here because I'm in my own home. So /root is the home of the root users. It is separated from /home because sometimes /home may got corrupted. Other users might find access to /home and many other reasons. So they separated home of the root users for easier rescue, easier emergency cases. You will have your home separated from other users if you are the root. Just like a dictatorship where dictator's home is completely separated from everyone else's life. We have one directory which is sbin. This is essential system binaries. The previous one, essential command binaries. On sbin, see for example grub, which can install grub on your system, or all things related to your disks, for example, as you can see. For example, fdisk can change your partitions, firewall can change your network, very important tools. Or we had the FSCKs checking file systems for errors, or network manager, and other super important things like mounting. You can add some disk to your server, and lots of other stuff, including, for example, routing systems. You can see commands for changing the routes of the networks, which can break your system if you use them wrong. All of these are in sbin. Most of them are only accessible to the root user. So /bin was normal command, /bin are the commands which are used by the users, essential system binaries. /serve, I have never seen a system using a /serve. I'm sure I have seen, but I cannot recall. Sorry. If you have a server which serves something, those things which are being served are placed here. For example, if you have an FTP server, you can put your files here. If you have a media server, you can put your media here. But most of the cases nowadays, each program handles its own data. So for example, if you're having an FTP server, most of the files will go to the FTP user's home. But anyway, serve, data for service provided by this system. /temp is very important to know. As you can guess, these are temporary files. For example, systemd wants to work correctly and needs to create some file somewhere. It creates it in /temp. Even if sometimes the user wants to create some temporary files, they may create them here. If I have a server which I want to move some file there and then install it, I will copy my file to /temp of that server, and then I will forget about it. In many cases, when you copy something in this /temp, as you can see, other users can see it, at least can see the name. Maybe they can see the contents, depends on the configuration of your file and everything. But when the system reboots, most Linuxes will delete whatever is in /temp. So it's really temporary place to put things there. You have /users, which is a secondary hierarchy. Strange name. You saw the primary hierarchy on /. On the root, we had an etc, we had a user, sorry, not user, was not a good thing. We had a var, we had a bin, we had lib. This is the primary place for all these files. We can go to the cd/user. Now I'm in user. If I do a ls here, you see again I have bin, lib, sbin, temp, and other things we had here, in addition to something like a include, games, local, share. This is a secondary hierarchy. The idea was, you install a Linux, some very important files will go to bin, some even more important files will go to sbin, and it will create a user. Now you want to add something to this system. For example, zip will go here, but you need rar, and rar is not default. Some user wants to install rar. It will go here, so everyone will have access to it. It's not only for myself. Everyone will have access, but it's in a secondary level. It's in user bin rar. Nowadays, it is not used in some of the major distros, including Fedora. I can do a ls on the root. Let me make it cleaner. I will do a long ls, and as you can see, my /bin is a link to user bin. So practically there is no bin. Bin is just the short link, a shadow, if a copy, like a shortcut to /user bin. The actual files are here. The lib is a shortcut to user lib. So these are combined into one, but Fedora decided to move everything in /user, but create /lib and point it to /lib under the user, just to keep things as a standard, but not complicated. So the actual things are here, but there is a link here. We will see about the links later. But you should know that the usage of spin is having the most important system binaries. User is a secondary hierarchy, so you can have a user spin. And I just show you that under Fedora, spin is just a copy of user spin. It's a short link to it. And at last you have this var, which is for variable. These are some variable files. For example, the logs. When you install Nginx and your manager says, I can see that Nginx has a problem. Go check the logs. You don't know where the logs is. It's very easy. Just go to /var because it's a variable thing. Go to log. Where is the log? Var log. And here check if you have an Nginx. Most of the time it will be here. Sometimes you might have a Nginx directory with other logs in it. Sometimes you might have an Nginx log only. Depends on the program and its configuration. But normally logs should go under var log. You see, it's different than temp. Temp is temporary or deleted after each reboot in most cases. Var logs are not automatically deleted. These are something which are variable. Other programs will add to them. For example, var cache. Some cache place for some files. So if you update your system using DNF under Fedora, for example, if you do a DNF update, we'll see this later, the files which are being downloaded to be used during the update will go under var cache where? DNF. So you can find the variable files here. If you have a database, sometimes it goes into var, whatever data you should have. For example, var, your database data. Depends on your database, your configuration, but this is logical. So let's do a quick recap. Bin were essential command binaries. Boot, what happened? Bin was essential libraries, essential command binaries, sorry. Boot was files to boot the system. Dev were devices. etc was important. Configurations. Home was user's home, normal user's home. Lib was libraries which other programs used or kernel modules. Media and mount were used for mounting the other file systems. We will see about them later. We will see practically about everything later. OPT was the add-on application software packages. If you are providing one very specific program on the server, you would install it in OPT. Root was the home of the root user. SBIN, essential system binaries mainly used by the root user. Serve, if the server providing some data, they will be inside the serve. Temp was temporary. Other users might have access to the same directory that you have. Don't copy something important here. And they are deleted after each reboot in most cases. User was a secondary hierarchy. So you would have user temp, user opt, user spin, user etc or whatever. And var were variable files, mainly log files. Knowing this helped me a lot. I believe knowing this help me to find my way in any Linux system. So know this. It may help you. On the next part of this section, I will talk about partitions. We will have an idea of the partitions, how they work, some programs, and understanding the LVM, and at the end being able to configure the design the hard disk layout. It won't be difficult. The reason is we are not going to do the actual job here. We will see mounting later, we will see partitioning later, formatting later. Here we are just understanding the concept. Be with me, I'm Jati.